This is the short notes for lesson 2 of unit 2. It's on function transformations. Function transformations. I'm going to go through it kind of quick. So if you are unable to write as fast as I'm talking, by all means, pause the video, get down what you need to write down, and we'll go from there. So function transformations. A transformation is a way to change the graph. A way to change the graph. So there are lots of different ways we're going to change f of x. One way is by moving it or translating it. So if I start with f of x, the graph of f of x minus k is exactly the same. So it's the same shape, the same size. The only difference is it's been translated. Translated means moved. So it's been moved k units to the right. So f of x minus k gets moved k units to the right. And then maybe as you would expect, f of x plus k is exactly the same as the graph of f of x, except it has been translated k units to the left. And notice that's kind of opposite of what you would think. Minus k, usually minus means in the negative direction, which would be left. That's opposite of what you would think because it actually goes right. F of x plus k plus is actually to the left, which is, again, opposite of what you would typically think. We graphed these functions in class and took a look at what happens if you added or subtracted at the end instead of next to the x. So the graph of f of x plus k on the outside this time, not next to the x, but on the outside, is the same as the graph of f of x, but now we've moved it up. That will move it up k units, and f of x minus k, like that, will move it down k units. So if it's tacked onto the end, plus means up and minus means down, which is exactly what you would think. Plus in the positive direction is up, and minus in the negative direction is down. And this will be consistent. Anything that's next to the x, is happening horizontally, side to side, and it's always going to be opposite of what you would typically think. Anything tacked on to the outside, either here or if we're multiplying by something out here, that happens up and down. And it is exactly the same way as you would think. And this will all hopefully make a little more sense once we start looking at a couple examples. All right. So the other thing, the other types of transformations that could happen is instead of adding or subtracting, we could be multiplying. So if I have a constant times f of x, if I take a constant and multiply by f of x, that's going to take the graph and it's going to stretch it vertically. So if that's my graph, it's going to take it and it's going to stretch it. Oh, I can't change the size, can I? I can't right there. Well, that's changing it both ways. Don't worry about that. It's going to stretch it vertically. So these points would stay the same, but if I grabbed it here and I grabbed it here and pulled up on those two, that is what it would look like. So it is a vertical stretch by a factor of k. To get the new values, you're just going to take all the y values and multiply them by k. Notice f of x is the same thing as y. So I'm taking the y values times k. Negative f of x is going to flip the graph over the x-axis. Flips the graph over the x-axis. That's bad. So if that's my y-axis, that's my x-axis. And the graph used to look like this. So if this is f of x, negative f of x would look like that. And it changes the sign of all the y values. So the graph's not perfect. That looks a little better. F of kx, f of k times x. Remember, this is consistent of what we thought about before. Anything next to the x happens side to side, so it's going to be a horizontal. And instead of multiplying, anything next to the x, it's the opposite of what you would think. So we're going to divide all the values by k. We're going to call that a horizontal squish. horizontal squished by a factor of k. It divides all the x values by k. And then f of negative x, you could probably guess, is going to flip the graph over the y-axis. Flips the graph over the y-axis. All right, so we're not going to do all these, but I want to take a look at a couple things. Let's start with, that is the graph of g of x. This is g of x right here. This graph is g of x. And let's suppose we are asked to graph g of x plus 3 minus 4. F of x plus 3 minus 4. So remember, anything next to the x is happening side to side, horizontally. And we do the opposite of what it says. So when it says plus 3, we're actually going to subtract 3 from the x values. So this point here is going to go left 3, and then also down 4. So this is a translation of left 3. This is down 4. Anything next to the x is opposite of what you would think. Anything on the outside is what you would think. So left 3, down 4. So this point translates to here. Left 3, down 4. That's this part right here. I'm going to translate this point. Left 3, down 4. And then this point. Left 3, down 4. And to make sure this line's correct, I'm going to take any other point on this line, probably this one right here, and translate that one left 3, down 4 also. And that is our new graph. That is g of x plus 3 minus 4. Let's try another one here. Let's suppose it asked for 2 times g of x minus 1. So 2 times g of x minus 1. Minus 1 is next to the x, so that tells us it's going to happen left or right. Because it's minus 1, we are going right 1. Next to the x is always opposite of what you would think. Anything on the outside is what you would think. So I've got 2 times, so I am going to multiply the y values by 2. It is a vertical stretch of a factor of 2. So I'm going to take a point, I'm going to move it right 1, and I'm going to take its y value, which is 2, and I'm going to double it. So now it's at 4. This point right here, I'm going to move it right 1. Its y value was negative 1, times 2 is negative 2. And a straight edge would help. This point here goes right 1. It had a y value of 2, times 2 is 4. Right 1 times 2. And then again, don't just copy this slope, because notice the slope of this line here used to be 1, but now it's 2, because I was changing things there. So find another point, this point here. Move it right 1. Its y value was 0, times 2 is still 0. Notice that slope has changed. And that would be the graph of this guy. One other type of problem we need to look at here. Let's suppose it tells us that f of x has a domain of negative 2 to 4, including the negative 2 but not the 4, and a range of negative infinity to 11. And it asks us to state the domain and range of let's go f of 5x plus 6. F of 5x plus 6. So the transformations I have here, this one, it's next to the x, so it's going to, something's going to happen to my x values. It's always opposite of what it looks like. So times 5, I'm actually going to divide my x values by 5. It is a horizontal squish by a factor of 5. And for my y values, this plus 6, anything on the outside is exactly what you would think. So plus 6, my y's, I'm going to add 6, which is going to move it up. So my x's, that's the domain. The domain is x's, and these are both x values. This is not an ordered pair where one's an x and one's a y. Because this is the domain, those are both x values. So I need to divide my domain by 5. So negative 2 divided by 5, and 4 divided by 5. This one had a bracket, it still has a bracket. Parentheses, still a parenthesis. I need to move up 6. Negative infinity plus 6 is still negative infinity. 11 plus 6 is 17. So hopefully that should get you a good start on this lesson. If you're running into questions, either in the notes here or when you get to the homework, please reach out and let me know.